Hi, welcome back to Practical Project Management Seminar 3, Understanding Quality Management. I'm Russ Hadfield, I'm one of the directors of Repton Projects. I think everybody's here today, so I think we're good to go. A little bit of a recap in case anybody missed the previous two seminars. I'm Russ Hadfield, I'm the Product Development Director of Repton Projects. I'm primarily responsible for the software that we produce and sell. It's called Project on Demand. It's a project management toolkit that allows you to run a project from a single dashboard, really. Go and have a look at it, please. It's on reptonprojects.com. Also today is the Managing Director, Nick Hollis, and Pete Storer, who helped us develop the 5 seminars. Between us, we've got 60 years combined change management experience in a wide variety of different commercial sectors. The course itself, just to recap a little bit, we've got 5 seminars, and the aim of the course is to develop an understanding of the organisation, planning, and the techniques for monitoring and controlling a project. A little bit of recap. We've had a seminar a couple of weeks ago where we talked about the introduction to project management, which primarily spoke about the waterfall project management methodology, which, if you recall, is about the startup phase, initiation, planning, design, execution, and closure phases. We walked all the way through those and pointed out the different artifacts that we would recommend that you produce, the tasks along the way. Last week we talked a little bit about risk management, we talked about risk identification, we talked about risk response planning and other things around there, around issue management and constraint management and dependencies and a few other things. But today we're going to talk about quality management. There are 4 or 5 things we're going to talk about probably over the next half an hour, 35 minutes today. And the first one is going to talk about quality management planning. So what I'm really trying to get at here is we're going to talk about trying to build quality into the project right from the very start. We talked about the initiation phase a couple of weeks ago, and this is really where we start to think about quality planning. Because if we build it in right from the start of the project, as you can imagine, we're going to be in a far better position to manage the quality throughout the life, rather than just hoping that we're going to get some quality at the end of it. We also need to think about the required level of quality as well when we're thinking about this. We're also going to look at scope and change management today, importance of actually maybe writing a scope statement and implementing a change management process that allows us to actually change in a controlled way the scope of the project if we need to halfway through. We're going to talk about testing and defect repair management as well. We're going to have to test any outputs that we have to deliver from the project. So we're going to have to make sure that that testing is done in a controlled manner as well. And any sort of defects that we find along the way, we can repair those and manage those accordingly. We're going to have a little chat about supplier management as well. Often that we can't deliver our projects on our own. We have to get in external suppliers, and we have to obviously sort of choose those very wisely. And then we have to manage those suppliers in order to ensure that they deliver quality into our projects as well. We'll talk a little bit about configuration management towards the end of the seminar. Don't worry if you've not heard of the term, but that's primarily looking at ensuring that our key artifacts are safe on the project, that we don't lose anything. And we've got a few sort of standards that we need to sort of stick to, like some naming conventions and all that sort of stuff. So we'll talk about that in a few moments as well. So if we start the process off by looking at number 1, quality management planning. I think the first thing to say about this is that we need to start off right at the very start of the project, maybe in the initiation phase, and I would suggest very strongly to you guys that you actually write what's called a quality management plan. What this does is it highlights basically how are we going to manage the quality of our projects going forward. So I've highlighted 6 things that we need to start looking at. This is not an exhaustive list by any stretch of the imagination, but it's the key things that I would certainly put into it. But as I said, it's not an exhaustive list. So if we have a look at these in turn, number 1 is how we define what's called our quality requirements. And our quality requirements are very important because if we look at those in terms of acceptance criteria, so if our customer is going to accept the end products out of our projects, for example, if we're building a website, we need to ensure that it is exactly what the customer requires. So there are certain things that the customer will accept or, more importantly, won't accept. So we need to start looking at what they are, and how we define those is in terms of what's called a quality requirement. I'm going to talk about these in turn a little bit later, so don't worry too much about it if you're not picking this up at the moment. Number 2, what quality assurance processes are required? And these are really to assure that we actually build the quality into the project. So if we don't have these processes in place, we might want to start about implementing them within our companies and within our projects, certainly, to ensure that we get the right level of quality. We're not just open at the end of the project in order to actually achieve the required level of quality. We also need to look at how we're going to manage the project scope. As I mentioned before, we've got what's included and what's excluded, but that might change, and it might even change quite a lot throughout the life of the project. So we need to be able to manage that, and we manage that via what's called a change management process. So we'll talk about that. What level of testing is required? We'll have to test everything, basically. We can't just hand it over to our customer and assume that it works. We'll have to have a testing strategy, and we'll talk about that in terms of the actual 4 steps that we need to take. We also need to look at how we're going to select and manage our suppliers. This is probably really important as well, because it's very difficult sometimes in order to go out if you having to choose a supplier from scratch. We don't know these people, we don't know how they work, so we need to be very careful how we manage these suppliers as well to ensure that they actually deliver the required level of quality that our customers require. We also need, as number 6, to how we're going to secure our key project artifacts. That was the configuration management thing that we spoke about on the previous slide or 2. So we'll talk about that a little bit later, and we'll hopefully give you some top tips about how to do that. Moving on to quality requirements. As I mentioned earlier, that this is really about ensuring that the customer is happy with what they get. They can accept it. So if we get these wrong and we actually deliver something to the customer that they're not happy with, it causes a whole world of pain. So if we're actually trying to gather these actual quality requirements, we need to really start doing it in the planning phase of the project. When we spoke about it in Seminar 1, we talked about sort of gathering functional and non-functional requirements, but we also maybe need to look at it as far as the acceptance criteria when we're doing that in terms of what's called a quality requirement. So an example really is quite simple sometimes. If we've got a new website project and there is a requirement that the website must be available 24 hours a day and 7 days a week. So as you can notice by that one, it's a measurable requirement. So if possible, we need to make these measurable. What that means is that we can then go to our customers and we can categorically prove that either it works or it doesn't work. So therefore it avoids unnecessary arguments really, a bit later down the line. So these need to be taken very seriously, and again, I do these during the planning phase of the project when we actually speak to the customer in a lot of detail to gather the functional and non-functional requirements. An example of a quality assurance process is, this example is about trying to build quality into the project, as I mentioned before. But what a quality assurance process really is it's required to ensure that the quality requirements are fully met. So there's no good just identifying what your quality requirements are without putting in a management process in order to ensure that we achieve what we set out to. Yet again, it's not just going to happen by accident. So in this example, that we've got a requirement that says there is a requirement that the new website is available 24/7. So how are we going to achieve that? We can either just hope for the best, hope that it will stay stable and it'll be available, or we can actually build quality into the project right from the start by implementing what's called these quality assurance processes. I've highlighted 6 of these here. These are not an exhaustive list by any means, and they can change all depending on what the requirements are. But these are just examples, really. So if I've got to assume that I need this website to be available actually all day and every day, we need to build this into the design of the actual website and the architecture that it sits on. So perhaps we might need to have some proper design standards that might be company-wide that we actually work to. So we're all not doing this independent things. We might want to be doing things that are industry best practice, for example. We also might want to talk about things like security standards. As it's a website, it's accessible from the outside world, obviously. So that is obviously also liable for hackers to hack into our system and bring it down. So we need to build actual sort of standards into the system itself so that we can avoid that wherever possible. So we might want to implement some security standards into this as a quality assurance process. As a wider business aspect, we might want to look at general what's called business continuity, which is primarily, for example, what if we have a large fire and the actual entire data center burns down? What's going to happen then? We might need to have what's called a business continuity plan that really sets out step by step what we're going to do in that event. As part of the business continuity plan, there's something called a disaster recovery plan, and this is what we're going to do in order to recover from a major disaster. And that can be just a server going down, it can be an isolated fire, it can be a flood, it can be all manner of things. How are we going to recover from this in order to ensure that our new website is available 24/7, because that's what the customer requires of us. So maybe we need to start building in some actual inbuilt quality assurance processes. And this can also go into the design itself, into the system design standards to incorporate that into there. We might also want to talk about backup and recovery strategies. Obviously, we've got maybe some data that we're storing in there, and we've certainly got code in the website. So what happens if we lose that for any reason, we accidentally delete something, how do we get it back? And yet again, if we can't, the requirement for the new website won't be available 24/7 again. So we need to actually ensure that we've got a backup and recovery strategy. And also we've got to look at how we're going to test this website to make sure that it has got the minimum amount of errors and bugs in there that might make it unusable. So we'll talk about the testing strategy again a bit later on, but those are the sort of general ideas that we need to build in as quality assurance processes. It's not an exhaustive list by any means. Talk a little bit about scope and change management. When we talked in the first seminar about the mandate, if you recall, we had a little bit about scope in there, and that identified a little bit about what is included and what's excluded really from the project. I would strongly suggest that we start maybe in the initiation phase in order to start building what's called a scope statement that expands on the mandate into more detail, so that we can put a little bit more flesh on the bones of this, so we can really start to understand what is included and what is excluded really from the project. This then can feed into the requirements in the planning phase as a real basis. We've got included and excluded. So if we fully understand what the scope of the project is, then we can start to understand any changes that we are asked to perform in the project lifecycle. In order to do that, we've got what's called a change management process. For example, I'm building this website and I've got 6 pages on the website, and one of them is an home page, and I've almost built the home page, and my customer looks at it and goes, not keen on that, can we have something different please? Can I have that red rather than green, or all sorts of other changes? So I need to manage these in a controlled way, because as in some of them are going to affect the scope of the project itself. So the first thing that we do in this change management process is we request whoever is requesting the change to write a change request. That doesn't mean to say that we can't help them prepare this, but I would strongly recommend again that we either sit down together and do it, or they do it, because it makes them think about why they want this change. What we really need to put into this change is really a description of what the change is, and almost a justification why we want this change. So that we're not just sort of saying, I don't like it, I want something different. It's, I don't like it because of X, Y, Z reason. So if we haven't got a good reason to change it, then we probably shouldn't be changing it at all. When we get the change request, we then analyse this and what's called an impact analysis. And that primarily is concerned with how much extra time is it going to actually take in order to deliver this change, and also importantly is how much extra is it going to cost us in order to deliver this change. So that is the impact on the project in terms of time and cost. Because also we might not have the time, or we might not have the money to do this, or we might not want to do it at all. So in order to make a decision, we need to set up what's called a change control board. These are a group of individuals that are normally quite senior within the company, and they've got an overall view of what's happening in the company itself, rather than just our individual projects. So if you haven't got one of these, I would strongly recommend you set one up. If you haven't actually got one and don't want to set one up, maybe use your project sponsor for this, and certainly allow them to make the final decision. But make the decision that is based upon the impact analysis, as I said, in terms of time and cost, rather than I'm just shouting for this change, I want it, therefore I'm going to have it. Item number 4 in the change management process is really about implementing the change. A lot of times when people just don't implement a change control process or a change management process, what they tend to do is stop the job and try to just implement the changes as they're coming along. We need to plan these into the project in a controlled way. And that actually gives us quite a lot of actual benefits, which I'll go into in a moment on the next slide. What that really gives us, actually, by performing that impact analysis and then managing the change in a controlled way by planning the actual activities into the project itself, rather than being very reactionary, is it minimises any disruptions that we might occur by having to do this change. It can also reduce the amount of sort of rework, because having done that analysis, we can maybe not do activities that we would have done before and then incorporate those into the change itself. It also increases actual quality, because we're not really trying to bodge a solution onto something. We're doing it in a controlled manner and we're planning it actually correctly. And we're also only choosing the right actual changes in order to implement that have got good justifications for it. So that can also increase quality. It can also obviously reduce costs as well, because if we've got to make the change and we plan it properly, we're less likely to basically screw something else up along the way that's obviously going to save us money. So that's really why we do the change management and how to do it. Moving on to testing and defect repair management. The testing strategy, we're going to have to test things, and that doesn't matter if you're building a house, building a website, or sending a man over to Mars as a project. We still need to test our end products of this. So I would like to suggest a testing strategy that's very commonly used. It's made up of 4 stages of actual testing. So what you've got here is unit test, integration test, sometimes called system test, mind you. Third one is a performance test, and the fourth one is user acceptance test. So just sort of nipping through these in turn. Unit testing is where we test individual components that are isolated from the rest of the project. The best example I can really give for this is if I'm building a house rather than a website. If I've got to install a tap into the sink, say, that I can test the tap in isolation that it works, I can open it, I can close it. And I can do that prior to installing the tap. When I install the tap, I connect it into the water pipe. I can then do what's called integration testing, so I can make sure that when I turn the tap on, water comes out, and when I turn the tap off, water stops coming out. I can then look at performance testing, which is really talking about volume, if I'm actually putting volume through this. So what that really is saying, on the same example on a tap, if I turn the tap on full, is it going to blow the washers apart and break the tap? And when I actually turn it off again, is it going to stop the flow? So am I getting the right amount of water coming out of the tap, or depending on how much open or closed it is? The fourth one is about user acceptance testing. This is where we just hand it over to the user and we allow them to actually sort of use it as they go into in a normal day-to-day process. As you can see, I've only used an example of a tap at the moment. This is applicable for the website as well, because we can obviously have to test individual pages of the website and how they link into each other if we actually navigate throughout the website. And we can also actually put a lot of users on the website in order to test its performance, and then we can let the users sort of play with it. It's a tried and tested approach to testing. So as a strategy, so we've got unit testing, integration testing, performance testing, and then user acceptance testing. So I'd strongly recommend that we implement that as your testing strategy. Defects repair. During the testing, chances are we're going to find things wrong. So we're going to have to fix these along the way. So a strategy is required. What we need to do is log these as a defect. And I think we spoke about things like logging things last week when we talked about risks and issues. We do this in the same way that we log a defect, because we might not be able to fix these immediately, so we need to keep a record of them. If we can, we need, in order to repair this in a test environment, and I know that a lot of projects you can't easily do that, but if it's a software project building a website, for example, you'd have a test environment that is independent to the one that goes live and into production for your customer. So if at all possible, we need to test these in a test environment. We need to perform also what's called regression testing. So after we've got a defect and we've actually repaired it and we've tested it in our test environment, we just need to have a check to see if we've managed to break anything else in the process of actually fixing this bug, for example, in the website. Have we managed to screw anything else up along the way? So we need to do what's called regression testing. Then, of course, we need to implement the solution, but we don't do it in a knee-jerk reaction. We plan it in as we would normally with any of these things. We log the defect, we repair the defect, whatever that defect may be. If we can do it in a test environment, that's great. If we can't, then we'll have to do a little bit more caution. And then we do what's called a regression testing to make sure we haven't broken anything else. And then we implement the solution. So that's sort of leading through into a defect repair strategy, following on from the testing strategy. Supplier management. This sometimes is one of the most difficult aspects of quality management because it's not always directly in our own control. Often suppliers go out and do whatever they want, and if we allow that to happen, then we're obviously storing issues for ourselves. So I think what we really need to do is to think about where, when and how we're going to spend the customer's money, because obviously they get rather upset if we waste it. So in order to do that, we need to select our suppliers very, very wisely. So there's just 3 actual methods of sort of doing this, if we can do it, depending on what it is that we need to buy. Obviously, a preferred supplier, if our company has got a preferred supplier list, then that's our first port of call, because we've worked in the past with these suppliers, so we've got a trusted relationship with them usually, and we know a lot about the suppliers because we've worked with them before. So if we can do, let's go for our preferred suppliers. If we haven't got a preferred supplier list and we can get a recommendation of somebody that we trust, just like real life outside at home, if you get a recommendation for an electrician or a plumber, we tend to go with that one. But obviously sometimes you haven't got that. The third method, depending on what it is that you want to buy again, you can use what's called an invitation to tender. So what we do there is we write down what we want and we issue it out and we invite people or our suppliers in order to write what's called a tender document back in again, and they actually explain how they're going to deliver what we want and what it's going to cost us, and then we can make a choice about that as well. Obviously that's normally for quite larger things. If we want to buy a little server or a little PC, we can go down to Maplin's or PC World and just buy it, obviously. But for the larger things, I'd be very careful about who we choose as suppliers because it can be fraught with danger. Supplier management, once we've actually selected our suppliers, we need to ensure that we manage them, because what we don't want to do is just let them go away for 6 months and then come back with a piece of software, for example, that doesn't work, or it's not what we need or what the customer wants. We have to ensure that we get quality and obviously value. So one of the best ways of actually doing this is to build a partnership with your supplier. So it's not us and them, we're doing one project and we're both feeding into the same project. So we need to try to build that, a relationship really with that individual supplier, because it's good for them and it's obviously good for us as well. What we also need, certainly for larger projects, is to have an integrated project plan. And we'll talk about the planning process next week. But please, let's not have a plan for our side of the project and then they've got another plan that's not integrated, because when we talk about any dependencies in that plan, we start talking about other things as well, that we actually need to have a view and sight of the entire project plan rather than just my part of it and then a supplier's part of it. We need to build in that integrated actual project planning process. Number 3, I would strongly recommend also that we have regular progress meetings, because if things go wrong, we need to know about them so that we can react to them. We can also be very proactive in these meetings by using sort of quality checks. So rather than leave it 6 months and then deliver the end product, we can actually check it on month 1, month 2, month 3, month 4, and we can check those actual progress against the required level of quality that we require. I think supplier management can be really difficult depending on your suppliers, but if you've got a good relationship, actually a good partnership, you've got an integrated project plan, you have regular progress meetings and you perform quality checks, you have at least got a very, very good chance of ensuring that you get a good quality service out of your suppliers. Final part today is about configuration management. So what we mentioned really before Configuration management is about trying to ensure that our key artifacts on our projects are safe and sound, and everybody's working from the same copy, for example. Everybody knows where it's stored, we can easily access it. It's obviously going to avoid any cock-ups along the way. So what configuration management is really about is about naming, storage and maintenance of key project artifacts. So a question really is, what are your key artifacts? And if we lost it, would it stop the project? So a key artifact might be a business case for the project. It might be your requirement specification. Think about what would happen if we lost the requirement specification. On large projects, or on very large projects, you could have maybe 6 people feeding into the requirements, maybe for 6 months. That would be 3 years worth of work. And if we lost it, what would happen? It would stop the project dead, and we'd be in serious amounts of trouble. So we need to maintain these artifacts as best we can. One of the methods of doing that is applying naming conventions really to these. And these are split up into 3 elements. One of them is an ID, which in this example on the slide is 001. And then the name of the document, which is called the requirement specification. So let's call it the requirement specification. And let's also give it a version number at the end so that we can increment those version numbers as we go through the development of that artifact. So in this case, we've got a requirement specification of version 0.1 and one that's got version 0.2. So if we actually come in order to edit this, we know that we need to edit the latest version. So we're all singing really from the same sheet. This is obviously better than calling it bob.txt. And I've actually seen this, kid you not. And I've actually been trying to look for a requirement specification if I've taken over a project, for example, from somebody else. And you go into the directory and you've got lots of artifacts that are named in a stupid manner, to be honest. And you can't find out really what they are. And it can cause you so many problems. So this also, it costs us nothing to do this. So why not do it? It's a little bit of effort, but it doesn't cost anything. So let's actually build in this best practice into our naming conventions because it stops us screwing up. Storage and backups. This is about what, where and how. So yet again, we need to actually store our project artifacts, normally in what's called a project directory. So if you look at the example in the middle line of that, you've got a backslash and then projects directory. That is the directory where we store all our projects. We might then want to create another directory underneath that, which is 001, and then our project name, which would be new website, for example. So then all our actual artifacts are stored within that project directory. Then we might want to store another directory for each phase, for example, of the actual project. So we know that if we want a mandate, it will be in startup. If we know that we want a business case, it will be in initiation. We know that if we want the requirements, it will be in planning, and the design will be in design. And the execution, all of the build and test documents will be under the execution phase. And then, of course, the artifact using the naming convention that we used on the previous slide. That's only the actual main storage. We can also use the backups in the same way. We need to back this up, so if we lose these documents, we can get them back. If somebody accidentally removes it, makes incorrect modifications to it, screws it up in any way, we need to be able to revert back to the backup. So in order to do that, we need to take a backup in the first place. So then again, we have the same structure, but rather than on the projects directory, we might want to have backups directory. I'd also recommend that we do that on an entirely different system, ideally in a different building, just in case we have that nasty fire again. Now we need to talk about what version control. We spoke about the artifact naming convention when we talked about having a version 0.1 and 0.2, for example. There is a convention with this that I would recommend that you use. And what that is anything that starts with a 0, as in 0.1, 0.2, 0.3, is what's called draft. And what that means is anybody can change it, as long as we do it in a structured way. When it is actually complete, And what I would suggest on your documents again when you do this is send it out for a review and then actually get that artifact approved. And then it's called baselined once it has been approved. So then we rename that document to version 1 or 1.1 or version 2 and 2.1. That indicates that it is a baselined document, that we can't just go and change it. We can, however, change it. We talked about the change management process, so we can change it via the change management process. So that's really about draft and baseline. A couple of other final things around quality. I talked a minute ago about stakeholder review and approvals. One of the best ways to ensure quality is get somebody else to look at it. 4 eyes are better than 2 often, especially if you're writing something. So let's actually look at the key stakeholders on the project and get them to review all these key artifacts. Let them look at the business case. Let's not hide it. Let's look at the requirements and get people to look at them. And then also make sure they get these approved, as in by your project sponsor or your customer or the steering group. Make sure that these are approved so that we can baseline them. There are ISO standards, and the main quality one is 9001. So if you want to go down a more formal route, you can explore that. It's not that complicated, but it can be expensive sometimes. But it's certainly worth you doing under certain circumstances. You've also got sort of quality gates. And what that is a concept of stopping the project for a little while, looking at the quality and then moving on. So when we talked about the actual individual project phases of startup, initiation, planning, design, execution and closure, they are ideal times to have a quality gate at the end of each stage. So that prior to moving on to the next stage, make sure that we're building quality into the previous stage prior to moving on into the next one. All very useful stuff. Again, that's about the end of what I've got to say around sort of quality management. If you forget everything else that you've been talking about today, please remember these 3 things. Build quality management into your projects. If we don't do this, we are assuming that quality management will just happen by accident. In my experiences, which have been many years, that does not happen. Use a change control process because it allows us to monitor change and basically control them in a very structured way. Make sure that we raise the change request. Make sure we do that impact analysis in terms of time and cost. Make sure that we go to the change management board or the project sponsor to get that approved or not, or obviously rejected. And also use configuration management. These artifacts can be very valuable to the project. As I said before, that you can also have a requirement specification that's actually taken 3 man-years to produce. Why are we just going to store it on somebody's laptop with a name of bob.txt? Let's not do this. It doesn't cost us anything in order to put this right. So that's the end of the quality management seminar. I hope you've got something out of that today. And if you have any questions, jump on our Facebook group. Try to get back to you as soon as possible. And next week we are going to talk about project planning and the methodologies about how to eat an elephant, of all things. So please join us next week, and I'll see you at 11 o'clock next Tuesday. Thank you. Bye.